Hello friends, I am Professor Chinmay Deshpande. Welcome you all for a video lecture series of Material Science. Today, in this video lecture, we are going to discuss Introduction to the Material Science. There was a man who was doing a maintenance work on a transmission line, and suddenly he got a shock. Which material was used for the conduction of electricity? Why he got shocked? Is it conducting material? Then what are the properties of conducting material? We have to discuss in this particular subject. Again, the same situation is described in this picture. When the metallic part of a ladder was touched to the line, then the person gets shocked. What is the difference between conducting material and insulating material? What are the different properties of insulating material and conducting material? And depending upon that properties, where it can be used, what could be the possible application? All these questions might be arise in your mind. So in order to get the information about all these, we have to study material science. Let's take an example of a Coca-Cola. Now if you observe here, the Coca-Cola is marketed in aluminum metal cans, which is shown in the figure 1, or in the glass, that is ceramic bottles, or in the plastic, that is polymer bottles. Why these materials are used in order to carry the Coca-Cola? What is the property of these material? We have to discuss in this subject. We know the SIM card. We always use a mobile. The functioning of our modern flash memory cards and the sticks that are used to store the digital information rely on the unique electrical properties of the silicon, a semiconducting material. So what are the properties of the semiconducting material? What are the applications of a semiconducting material? We have to discuss this in this particular subject, that is material science. Suppose there is a plug of 13 ampere fuse. Now, which material should be used as an insulating? What is the material that can be used for conducting electricity? Next, suppose there is a transformer. Now, then, for operation of a transformer, which material is used? For a primary side winding, for a secondary side winding, whatever the windings are shown here, what is the material of that winding? We have to discuss all these things in a subject, material science. So let's discuss first what is material science. Can you think over it? Okay, I can help you to frame the meaning of material science. The word materials here does not refer to all the matter in the universe. If this were so, it would include all the physical sciences and the life sciences from astronomy to the zoology. Further, we can restrict the definition only to the matter useful to the mankind. Even here, the range is too broad for the purposes of the engineer. For example, we can list a large number of things useful to the man, such as food, medicines, explosives, chemicals, water, steel, plastics, and concrete, only some of which qualify as an engineering material. We then have to be more specific and define materials as that part of matter which is useful to the engineer in the practice of his profession. So, the word material here does not refer to all the matter in the universe. One can define the material science as, before that we have to discuss what is a science. The word science in the phrase refers to the physical sciences, in particular to the chemistry and physics. So one can define a material science as, it is an interdisciplinary field involving the properties of the matter and its applications to various areas of the science and engineering. It includes elements of applied physics and chemistry, as well as chemical, mechanical, civil and electrical engineering. Material science and engineering plays a vital role in the modern age of science and technology. Various kinds of materials are used in the industry, housing, agriculture, transportation, etc. to meet the plant and individual requirement. Historically, the development and advancement of the societies have been intimately tied to the members' ability to produce and manipulate the materials to fill their needs. In fact, early civilizations have been designated by the level of their materials development, that is, Stone Age, Bronze Age, and Iron Age. The development of many technologies that make our existence so comfortable has been intimately associated with accessibility of suitable materials. For example, automobiles would not have been possible without the availability of inexpensive steel or some other comparable substitute. In our contemporary era, sophisticated electronic devices rely on components that are made from what are called semiconducting materials. Hence, I can define it again in a very well manner and precise manner as material science is nothing but the science which deals with the properties, characteristics, behavior of the material under various situations such as solid, liquid and gaseous materials, and depending upon its properties and characteristics, its usefulness in the particular application is called as material science. But obvious, there is one question in your mind while studying this subject for a course of electrical engineering. That is, why to study this subject? There are thousands and thousands of material available, and it is very difficult for an engineer to possess a detailed knowledge of all the materials. However, a good grasp of fundamental principles which control the properties of various materials help one to make the optimum selection of a material. So as a student of an electrical engineering, one should know the basic kinds of materials which can be used in manufacturing processes of any machines or electronic and electrical equipments. Let's discuss the course objective of this subject. First is explain the classification, properties and characteristics of electrical engineering materials. Second, describe the applications and measuring methods for the parameters of dielectric, insulating, magnetic, conducting and resistive materials. Third one is illustrate solving of simple problems which are based on dielectric, magnetic and conducting materials. Next is impart a knowledge of nanotechnology to the electrical engineering. Now the present era is related to the nanotechnology. So how this nanotechnology is going to be implemented for the electrical application purpose, we have to study in this course. Demonstrate testing methods of dielectric, insulating, magnetic, conducting and resistive materials as per Indian standard. So these are the course objectives. Let's discuss a case study of a plug. What will be the selection criteria for 15 ampere electrical plugs? The first one is the said electrical plugs are designed for the required amperage. The plugs are electrically safe to handle. Means the insulating material has to be there in order to prevent it from conducting electricity. The electrical plugs are cheap to produce. The material that can be used for the production of these electrical plugs, its cost should be less, but in the same way its application will be in such a way that it will fulfill our criteria. And the plugs should be rigid enough so that they do not break easily while in use, that is in handling. So these are the selection criteria, and based on these selection criteria we have to choose a particular material in order to prepare a 15 ampere electrical plugs. Let's discuss course structure. The code for this subject is 203142. The teaching scheme is there will be 3 lectures per week and practical 4 hours per week. For a theory it has 3 credits and for the practical it has 2 credits. The examination scheme as per Savitribai Phule Pune University is that there will be an in-sem examination having 30 marks, and this in-sem examination will be based on first 2 units, whereas the end-sem examination will be of 70 marks and remaining 4 units, the exam will be based on remaining 4 units, that is 3, 4, 5 and 6. There will be a term work internal marks with 25 and there will be oral based on all 6 units having marks 25. Let's discuss the syllabus of material science as per Savitribai Phule Pune University. The unit 1 is dielectric properties of insulating material. In this, we have to study the parameters of dielectric material. That is, what is dielectric constant, what is dipole moment, what is the concept of polarization, polarizability, then what are the types of polarization, that is electronic, ionic and orientation polarization. Introduction to the polar and non-polar dielectric materials. The equation which is very important, that is Clausius-Mosotty equation. What is piezoelectric material? What are the applications of piezoelectric material? What is pyroelectric material? What is the concept behind that? And ferroelectric materials, its application also. Then we have to study dielectric loss and loss tangent and concept of negative tan delta. Means whatever about insulating material and dielectric material, we are going to complete a syllabus related to it in unit number 1. Unit number 2 has two parts. Part A is related to the dielectric breakdown and part B is related to testing of materials. So it includes concept of primary and secondary ionization of the gases. What is breakdown voltage? What is the breakdown strength? What is the formula for breakdown strength? What are the factors that affects the breakdown strength of solid, liquid and gaseous dielectric materials? We have to study this part in part A of unit number 2. Whereas in a part B of a unit number 2, there will be an explanation of testing of the material with the objectives. What are the equipments required for testing of the material? What is the necessity circuit diagram for that? And what will be the observations that we are going to take from that particular experimentation. So it includes measurement of dielectric loss tangent, that is tan delta, by shearing bridge, Indian standard 13585-1994. Second is measurement of dielectric strength of a solid insulating material in Indian standard 2584. Then third one is measurement of dielectric strength of liquid insulating material, Indian standard 6798. And fourth one is measurement of dielectric strength of gaseous insulating material as per Indian standard. Now, based on this unit number 2 part B, we have experiments also. So we'll see experimentation in detail in the next slides. The third unit is insulating materials, its properties and applications. Now in this particular unit, we are going to cover what is basically insulating material, what are the characteristics of good insulating material, what is the classification of insulating material, what are the insulating materials, solid insulating materials that can be used, that is paper, pressboard, fibrous material, ceramics, mica, asbestos, resins, liquid insulating material such as transformer oil, varnish, ascarel, then insulating gases like air and SFCs, that is sulfur hexafluoride. Insulating materials that can be used for a power and distribution transformers, rotating machine, capacitors, cables, line insulators and switch gears. So in all, in this particular lecture, we are going to cover a concept of insulating material, its characteristic, its classification, then different materials that can be used as per its application. So in that we have to study its characteristics, then its properties, then what are the possible application of solid, liquid and gaseous insulating materials in electrical engineering. Unit number 4 is related to the magnetic materials. So in that again we have to study a basic concepts related to the magnetic material, that is permeability, magnetic susceptibility, magnetization. Is there any classification of magnetic material? Yes. The magnetic material gets classified into 4 materials. So we have to study this in diamagnetism, paramagnetism, ferromagnetism and ferrimagnetism. Then ferromagnetic behavior below critical temperature, spontaneous magnetization. What is anti-ferromagnetism? What do you mean by ferrites and its applications? Then applications of the ferromagnetic materials. Magnetic materials that can be used in the electrical devices such as transformer core, core of rotating machine, soft magnetic materials and hard magnetic materials. Means unit number 4 is totally related to the magnetic materials. its properties, its classification, and depending upon its properties, where it can be used. In a unit number 5, we are going to see what is conducting material. So what are the general properties of the conductor? Then what are the materials that can be used in the electrical industry for the purpose of conduction? That is copper, aluminium and its application. Material with high and low resistivity, that is constantan, nickel chromium alloy, tungsten, canthol, silver and silver alloys. Characteristics of the copper alloys, that is brass and bronze. Then electrical carbon materials. Materials that can be used for the lamp filament, solders, metals and alloys for different types of thermal bimetal and thermocouples. So if you observe, unit number 3 was related to the insulating material. Unit number 4 was related to the magnetic material. So same way, unit number 5 is related to the conducting material. In that we have to study its basic concepts, its basic properties, what are the types of conducting materials that we can use, and depending upon its properties, where it can be used in electrical engineering. Unit number 6 is related to the nanotechnology. This is very important unit. In this particular unit, we are going to learn concept of energy bands and various conducting mechanisms in nanostructures. Carbon nanostructures, carbon molecules, carbon cluster, carbon nanotubes and applications. Special topics in the nanotechnology such as SET, that is single electron transistor, molecular machines, BN nanotubes, nanowires, nanomaterials used in the batteries, photovoltaic cells in supercapacitors. So this particular unit is related to the nanotechnology. This is what is a syllabus of material science, which includes a 6 unit as per Savitribai Phule Pune University. Let's discuss the practicals for this particular subject. Now there are two parts of the practical, part A and part B. Out of 25 marks which are allotted for the term work, 15 marks will be based on whatever the performance done in part A experimentation. So there are total 12 experiments, and out of which we have to conduct 8 experiments. First one is dielectric strength of solid insulating material, measurement of dielectric strength of liquid insulating material, measurement of dielectric strength of gaseous insulating material. So these three are the first 3 experiments. Then fourth one is related to the magnetic materials, that is hysteresis loop of a ferromagnetic material. Next one is to understand the principle of thermocouple and to obtain the characteristic of different thermocouples. This is related to the conducting materials. Next, to measure the insulation resistance and kVAr capacity of a power capacitor. Next, to measure the resistivity of high resistive alloys. It is related to the unit number 2. To observe development of cracks due to aging on different insulating materials, that is bakelite, perspex, polyester, mica, fiberglass, etc. These are the types of insulating materials. And ninth one is testing of resins and polymers. Next experiment is measurement of tangent of dielectric loss angle, tan delta, of solid or a liquid dielectric materials. Next is measurement of flux density by Gauss meter. And the last experiment is related to the visit report. Now there will be a compulsory visit for this particular subject related to the manufacturing of batteries, capacitors, cables and transformers. So out of these, there will be a one visit to particular industry and we have to submit a visit report. The part B carries 10 marks from a term work. Now there are total 6 activities from the list which is given below, and out of which 1, 4 and 6 are compulsory. Now the first one is review of a research or online literature from latest journal papers or transactions related to the different insulating, magnetic, semiconducting and conducting materials, advanced materials, developments and their applications. We have to search the papers based on the material science, and from the literature which is collected from the internet or from the transaction papers, we have to draft a paper or we have to give a presentation in front of students. Second one is detailed case study of complete insulation system in a transformer. So what are the types of insulating materials that can be used in the transformer? Then we have to compare it, whether it is solid, liquid materials, and study the recent advances related to the major and minor insulating materials. So this is also very important experiment related to the study. Third one, detailed study of a patents on castor oil used in the transformer, its properties and comparison with other liquid insulating materials. Fourth one, this is very prime topic, mini project on development of a prototype of various electrical gadgets, right from draft of the specification, its design, selection of the conducting, magnetic and insulating material. Next experiment is testing and diagnosis of induction motor, cable, transformer insulation by measurement of polarization index, dielectric absorption ratio, step voltage, dielectric discharge and RAM testing using 5 or 10 kV IR tester. Next is laboratory visits or a survey or role play, games, debates, any activities focusing collaborative student-centric active learning on industrial, social, sustainability or public health or safety, ethical, cultural, societal and environmental aspects related to the advanced material presentations of industrial case studies related with material science. So there will be a games based on material science, there might be a role plays related to that. Next is 2 or 3 household appliances like mixer, motor, ceiling fan motor, etc. can be opened up by the students either individually or by a group of students and analyzed with respect to the materials found in it. Name each material used and to which category of materials does it belong. Other applications of the same materials can be listed. So this is very also interesting experiment. Detailed study of insulation system of resin casted transformer, comparison of various resins, study of testing of insulation system with applicable Indian standard, IEC or IEEE standards. So let's discuss first what is material science. Can you think over it? Okay, I can help you to frame the meaning of material science. The word materials here does not refer to all the matter in the universe. If this were so, it would include all the physical sciences and the life sciences from astronomy to the zoology. Further, we can restrict the definition only to the matter useful to the mankind. Even here, the range is too broad for the purposes of the engineer. For example, we can list a large number of things useful to the man such as food, medicines, explosives, chemicals, water, steel, plastics and concrete, only some of which qualify as an engineering material. We then have to be more specific and define materials as that part of matter which is useful to the engineer in the practice of his profession. So, the word material here does not refer to all the matter in the universe. One can define. These are the textbooks and reference books from the syllabus. So, thank you for watching introductory video of material science.